All right, I think let's go ahead and get started. I have a few housekeeping items to run through, so that'll give folks a few more minutes to join as well. But good morning, good afternoon, good evening, depending on where you are joining us from in the world today. And thank you all who are tuning in. I'm Caitlin Barnard. I'm part of our marketing team here at Kong, and I'd like to welcome you to Tech Talks by Kong. This is a webinar series dedicated to our technical developer audience, featuring all open source products and topics relevant to you with extended live demos. At the end of today's presentation, we are going to open it up for Q&A and discussion. Please feel free to leverage the chat function throughout. We'll be keeping an eye on that, but if you have any questions for the presenters, please enter them using the Q&A button on your Zoom toolbar. You should see that at the bottom of your screen. And then so we don't lose track of them in the chat, and we'll make sure to get to all of those. This session is also being recorded, so you will receive a copy of the recording in your email. So today, I'd like to welcome our guests from Opitz Consulting. We have Sven Bernhardt, Chief Architect, and Fabian Hart, Solution Architect. So today, they are going to be showing you how to build and manage multi-cloud applications using Kuma. So with that, I will hand it over to you, Sven.
Thank you very much. Yeah, also from our side, welcome and for joining our session today. And with that, we will directly jump in. So what we are going to tell today is give you an idea how a service mesh can help you to build and manage multi-cloud applications. Doing so, we just want to start a brief introduction about service mesh basics, why we need a service mesh. Then we'll briefly introduce Kuma to you for those of you who are not familiar with Kuma, and then we will have a demo slot where we will show what we've built so far, and afterwards we will do a short conclusion. With that, let's jump in. About service mesh basics. Why do we need a service mesh? So the world is rapidly changing. So we are coming from a very centralized world that was very static, mainly on-prem, where we have a lot of monolithic application architectures in our system landscapes, mainly based on virtual machines. And while we have to maintain this IT system landscape on-prem, we had a lot of manual work to do while it comes to changes and all that kind of stuff. On the other hand, today, what we see is that the world is moving to a more decentralized world, and where environments are moving from a static one to dynamic environment, where we have not only on-prem, but we are moving our application workloads over to the cloud, and not only to one cloud, but also to multi-clouds. Then we are going away from the monolithic application design more to a microservices or even serverless application architecture. We are running our applications workloads on containers and Kubernetes, and we are doing a lot of stuff to automate our application and also infrastructure delivery to make it more efficient, to free up development resources, and to make the stuff more maintainable. With this shift, what we see is that we are moving away from this having a few big applications to having a lot of distributed services. So the number of services and APIs are increasing, and at the same time, while this increases, and all this the service network we are creating, running in a distributed fashion, communicating over the network, is lacking control and visibility. And this is exactly one of the use cases for introducing a service mesh. So to have control and visibility also with respect to who is accessing my service landscape and all that kind of stuff. So it's all about basically all about connectivity at the end. So the connectivity between the services internally as well as from the external world to our internal service world. So so we have connectivity challenges on different levels. So we have it in-app. So while we're building applications consisting of multiple microservices, we have in-app remote communications that we need to ensure. We have app-to-app connectivity when different apps are communicating with each other. We need to ensure the connectivity, and especially also if we are exposing our services as digital products, we also need to ensure that these digital products are available to our end customers to ensure a proper user experience for our end customers. So, and for all that, we need a service mesh. And why a service mesh? Because connectivity or all the challenges I said, connectivity, so with respect to the visibility and the control, we need at the service level to ensure different aspects. So when we build services, we need to ensure that they are secure. Exactly. We need to ensure that they are secure, that they are expose observability data like logs, like metrics, like traces, so that we make our service landscape, our distributed service landscape observable, that we can track down problems that occur in this distributed world. And we don't want to go to each container instance and look into the logs or look into the specific metrics of this container to analyze it. So we wanted to have a single pane of glass, an observability stack where all the information are consolidated, right? And here we see that it is in the in-app level, also routing challenges and all that kind of stuff, and versioning especially. So maybe we introduce more than just one service version, and then we wanted to define respective routing rules, in which case traffic needs to route to the one or the other service version. And we also have those challenges in the app-to-app communication world, and when the traffic comes from the outside world in our service ecosystem. And ensuring that on an implementation level is hard, because we are building applications as microservices. This means we have a lot of freedom from a technologies perspective. We can build our microservices in Java, we can build it in Go, we can build it in Node.js, we can build it in Python. And this means that we need to ensure that the frameworks we use are compatible with each other and expose the data in a way that our observability platform can work with it. Same applies to security. We need to use the same libraries or compatible libraries for implementing OpenID Connect, for implementing other authentication and authorization mechanism. And this is very hard to maintain, and also requires the developers to care about all those aspects. But we don't want our developers to cover those aspects. We want them to build business logic, right? So having a service mesh frees up developer resources, because what we are doing is, and we'll see this on the next slide when we look into service mesh. We have, with a service mesh, we have a dedicated infrastructure layer that cares about this service-to-service communication, no matter if it's the in-app service level or the app-to-app service level, right? And to make the the communication between those services reliable, secure, and observable. So a service mesh is mainly based on a pattern called the sidecar pattern. So when I use a service mesh implementation, the service mesh infrastructure spins up data plane proxies to each microservice we have, and then the communication between the services always goes through the proxy. So inbound as well as outbound. So, and the proxy applies all the policies that we configured using the control plane in our mesh, like security, for example, MTLS communication between the services. It also cares about collecting all the observability information and all that kind of stuff, right? So a service mesh as such helps us to rather configure all these cross-cutting concerns we saw before, rather than implementing them in the code. So introducing a service mesh means we can apply all those aspects without changing a single line of code. And that's a great thing, and also is good with respect to the developer productivity. So looking to a specific implementation like Kuma, which is the next chapter. Kuma is the open and now a CNCF project, which was donated to the CNCF by Kong in 2020. And it's a completely Envoy-based service mesh implementation, which is platform agnostic. This means you can deploy Kuma everywhere, on-prem, in every cloud, and especially Kuma was thought from the very first beginning not just dedicated to microservices and containers, but also including the VM-based world, because we usually don't start on a greenfield. We start on existing and over the year grown IT system landscapes, where we also have all those VMs around, and we maybe want also to include them in our service mesh. This is why Kuma can be called universal, and it's quite simple from a setup perspective and getting started perspective. And we will show this also in the demo, how it works. We don't go to all the steps to get it running, but afterwards we will also share the code base with you, that you can get your hands on the stuff and play around with the code and build up your own multi-cloud, multi-cluster mesh. Yeah, and we can install Kuma in a standalone architecture, which means Kuma is just dedicated to a single Kubernetes cluster. So we install everything there, and we are just working in our Kubernetes cluster, and that's it. But that's not the real world use case. It's good for demo. But if we go out and implement it in the wild, we are usually going over to a multi-zone mode, which means I have a different architecture. I have, in this, you can see it in the picture, that we have two Kubernetes cluster, and basically what we have Kuma installed into each Kubernetes cluster. And we have also a so-called global control plane, which is not here in the picture, but we will see it in the demo later on. And the global control plane is controlling the zone control planes. So you do all the configurations using this global control plane, and the zone or remote control planes are managing all the services within a specific zone. And the mesh in this example spans the zones. You can also define different meshes within or over these zones, but you can also start with, and this is also what we see in the demo, just have one zone spanning all the zones. So this means you apply all policies directly on the mesh level, and this affects all the zones and all the services directly, which is great. So, and now Fabian will talk a little bit and give you insights about how Kuma works and what you need to know when you wanted to get started with it.
Yes, thank you, Sven, so far. Yeah, we'll go ahead with some more details about Kuma, like networking and CNI stuff. So as we have learned before, you can use the data plane as a sidecar next to your application containers and pods. And then in Kuma, you can just use an init container to configure network stuff, or you can use a dedicated CNI plugin as well. So if you install the CNI plugin instead of the init container usage, you will have a dedicated daemon set spinned around your Kubernetes cluster, and this is watching all the injected labels on your pods, like as you can see on the slide here. So you have these annotations and labels on your dedicated pods, and the CNI will configure your network with the usage of IP tables and so on to configure the networking and routing stuff on your Kubernetes node level. This is the way the transparent proxying is realized in Kuma. So you can just have the routing out of your data planes going over a virtual network through your Kubernetes nodes to other data plane instances, and after all, reaching your application directly. So it's basic installation just on top of your Kubernetes distribution, and it's managing the whole transparent proxying stuff instead of the default init containers, which are doing the same and using IP tables to configure your network as well. The next one is the init container. As you can see on the picture here, I've already said something about it, and it's the init container is the yellow one here, which comes up at first and configures the network and IP table rules. And after that, the data plane and the API pod is spinning up, and the network is already configured, and you can do your routing from data plane to another data plane instance, so that you can reach your, let's say, from your front end, your backend application. Then which is very important in service mesh implementations in generally, is the DNS setting, and this is the way it works in Kuma. You have the envoy-based data plane instance next to your application, as you can see in the picture. This is the pod around your application. There's the data plane proxy, and the data plane instance is an envoy-based data plane, and this is managing your DNS resolution in your mesh. So if you have some logical service names in your mesh, like this one here, it's billing.mesh, and it has a virtual IP. It's 240.0.0.1 in this case, and the DNS resolution is done directly in the envoy and data plane in this case. So if I ask for billing.mesh, I will get the virtual IP of my overlay network, and can directly communicate to another data plane proxy right over the configured IP table rule, which is done on the network layer, as I've told you before. So this is the way the DNS resolution is done, and I will get from data plane to another data plane. This is in one zone, yeah. So if there's no physical network break off in between, we can just go directly from a data plane to a data plane. But if we have another zone and another Kubernetes cluster in, let's say, another cloud environment, we will have to step over the zone ingress, which is the pod which is managing the ingress traffic to a dedicated zone. So if I just go from this data plane proxy and want to get the invoice.mesh address, I will also get this address and virtual IP from my data plane proxy, and I will just reach the zone ingress of the other zone. So I will go with my routing and network traffic. I will go out of my Kubernetes cluster directly to the zone ingress of the other zone. And this zone ingress is doing the proxying stuff to the data plane proxy of my target application. And this is the way sales.mesh goes directly through the zone ingress to the final data plane proxy and my sales API as the last step. Okay, this is the way full routing is done in a service mesh like Kuma. And it's very important to understand these basics, I think, if we want to use multi-zone mesh. Then there's another topic, the zone egress. We will not show this in our demo in a few minutes, but it's very helpful if you have, let's say, an enterprise system and your department has a big firewall in front of your Kubernetes clusters, and you just want to have one single point of outgoing traffic. This is important for the other zone, that they can configure their firewall for, let's say, one special IP address of this zone egress point. So you can do the routing and firewall rules, define them directly to one IP address or one special full qualified domain name, for example. So if you deploy these zone egress, it's kind of ingress, but the other way around. Yeah. So the data plane is communicating with its outgoing traffic, and all the traffic is leaving the Kubernetes cluster over the zone egress deployment. So it's just a proxy to get all the traffic out of the cluster with one IP address and one single point of contact. Okay, and then we will step into the demo. I think Sven will tell you some details about our demo showcase, and I will just go ahead with the demo in a few minutes.
Rather quickly introduce the demo to you, because the most of it we will see while Fabian is showing it live. So what we did is we span the multi-cloud mesh using two clouds. We once have the Oracle cloud and a Kubernetes cluster there. Within this Kubernetes cluster, we introduced Kong ingress controller as a central entry point to our mesh from the outside world. Then we deployed our demo application, so the counter demo app, which consists of two containers, a UI application and a Redis cache behind it. Yeah, and then on the other hand, we have the another cluster or another two Kubernetes cluster in the Azure cloud. One cluster for our zone, where we exactly have the same application deployed. And on the other hand, we have this global control plane in a separate Kubernetes cluster, which is a management cluster, and we need to separate the global control plane and the zone control planes from each other because of the way the CRDs are implemented. And if you put them in the same cluster, you run into conflict. So you need to separate it, right? And usually we have more than just the global control plane is in this management cluster. In real world scenarios, we also put the observability stack for our mesh there and additional components like secret stores, like HashiCorp Vault and all that kind of stuff. So, and the overall demo, we can see on the next slide how we build it. Oh, this is the overall demo, so the big picture. With no more details than what I was just telling you, just for an overview reason. And Fabian, I would say we jump into the demo, right?
Yeah, good idea. So first of all, I will just talk about the scripts we have used. We have automated the whole setup with a combination of Ansible and Helm scripts. This you can see here, there are two inventories, one for the Azure stuff, like the global control plane installation and the zone control plane for the other Kubernetes cluster in Azure as well. And the second zone, which is running in OCI. There are the basic variables defined, like the URLs, the domain names, and ports, and so on. And then we just template the values YAML for the Helm charts, generate all the deployments for the Kubernetes clusters, like the global control plane installation, the deployment services, ingresses, and so on. And the second step, we are doing some configuration for some basic configuration stuff, like configuring a mesh. In our case, it's a mesh called demo, which is configured, and some default policies and so on. You can also configure this with our Ansible script in this case. So as Sven already told you, we will publish this one on GitHub, and you will get the link in our presentation afterwards. So you just can try this on your own.
Okay. Then I would say we jump right into our Kuma UI. So what you see here is the Kuma UI. This is the overall status of our Kuma mesh. What we can see is that we have 2 zones online, that we have 9 data plane proxies online, that we have 6 Kuma services available, and that we have 1 mesh configured. So what I told you before, so we have a multi-cluster setup and 1 mesh spanning that 2 Kubernetes clusters. And we can see here that we have here the zone control planes registered to the global control plane. So everything what we do here is always at the level of the global control plane when it comes to all the management, all the configuration to the mesh, and all that kind of things. And we can also see the versions of the zone control planes. It's the 2.0.0, which was just released a few weeks ago. Maybe
as you can see here, I think we don't have the egress deployed, as I already told you. Yeah. Just the ingress is deployed to communicate in between these 2 zones.
Exactly. So the egress is optional, and as we don't have the requirements here in this demo for having a centralized output point, we just decided to not configure the zone egress. So maybe we can jump to the service world. So here you can see all the services that are deployed to our mesh. You can see the type of the service, and here's a different. We have internal type services and we have gateway delegated services. The difference is that the internal type services are let's say real services that are completely integrated in the mesh. So all incoming and outgoing communication is going through the Envoy proxy, but we have use cases where we cannot have the proxy in front of the original service. So for example, for the ingress controller, which needs to be reachable from the outside world without a proxy between the client request and the container, we need something like a gateway delegated. So this means we have on the inbound side, we don't have a proxy, but on the outbound side, we have the proxy so that the communication within the mesh can happen properly. So that's the difference here. Yeah, so what we also see is that we have a single pane of glass to see which services we are running in our Kubernetes clusters. So it's like a service registry, if you will. So and now what we will show in the following is how we configure the mesh. So we started the mesh configuration, and if we head over to the mesh configuration, we can see that we have MTLS enabled, that we have the logging feature enabled, that we have metrics and tracing enabled, and we don't have the locality aware load balancing enabled. We have this disabled. We'll come to this later, but we'll start with the MTLS. So what we learn from that is that all the communication happening between the services within our mesh is MTLS secured. And by default, within the mesh, all communication between all services is allowed. And we can see this if we go to the traffic permissions. And what we wanted to show is what happens if we remove that certain policy that all the traffic is allowed. Now, if we go to our application, maybe we should show the application first, Fabian, the Kuma demo.
Yeah, this one is the typical Kuma demo application.
Yeah.
And as you can see, we have here the front-end application. If I will do a refresh, we have just a version number here, and we can see it's running in OCI cloud. In this case, in our OKE cluster in version 1.0. And in the as a backend application, it's talking to Redis store. And in the Redis store, we have the AKS zone in this case. And if we're using it, it's definitely switching here. So we saw in this service layer here, we see the Redis application has a data plane proxy 2 of 2 up and running. Yeah, this tells us it has 2 instances of this service. So there are 2 data plane proxies for Redis. One is over here. As you can see, it's running in AKS zone, and there should be another one in OCI. Yeah, this one. So there are 2 instances of the data plane proxy running. So there are definitely 2 services, upstream services running with the Redis store. This is the reason why it's changing if we increment the counter here.
And if we refresh the web application, it's also changing. So now with the web application, we are hitting from the ingress, we are hitting the AKS cluster, so the Azure cluster. And while incrementing it, we are hitting different Redis, either deployed in AKS or deployed in OCI. So let's kill this this traffic all permission, Fabian, and then show it again. And
check, yeah, this is the right cluster.
Great.
So we can.
So configuring the mesh is done by Kubernetes manifests. Kuma provides the respective CRDs for that. We can just delete it. So now the traffic permission is gone. So we don't have.
You can see it over there. No data.
If we go back to the application, what we will see is that when we refresh the application, we don't have an application anymore. So we are hitting the ingress gateway, and from that on, as the ingress gateway or the ingress controller is not allowed to access any of its endpoints configured, we are not able to call our application again. So now we have to explicitly allow the ingress gateway to call out to the front-end app. And this is done by applying the respective traffic permission for the app. So the traffic permission is set up again. So if we refresh the page, it is back in action. And if we try to increment, it's not working. Why it's not working? Because we haven't allowed the front-end application to access Redis, as this is still restricted. So we need to define the respective traffic policies for the Redis for the app to access Redis. So it has been created, and now the application is back in action again. And as we can see, we are hitting either the OCI or the AKS. The next thing we wanted to show you is an aspect which we were talking briefly when talking about the challenges why we need a service mesh. If we now have different versions of our service, and we wanted to introduce a new service version and just try out how this new service version reacts and behaves. So in the sense of a blue-green deployment, and what Fabian is showing is the so-called traffic route policy. So what we do now is that we are routing 90% of the traffic to the Redis container and another 10% to this Redis v2 container. So, and this we can also see while incrementing the counter. So here we're hitting AKS, here we're hitting OCI, and you will see just 10%. Yeah, there we go.
There it is.
So most of the traffic goes to the AKS and OCI, and just a few requests are also hitting the v2 of the new service version. So with that, but just configuring, we can implement blue-green deployment scenarios easily, and also just increase the respective weight on how much requests should be routed to the new service until the old service version is retired or can be retired, right? And that's a very cool thing. A last thing what we want to show you is, and we saw that just before, is this locality-aware load balancing. What we see now is when we hit the application and when we increment the counter, that in the back we are hitting either the OCI or the AKS Redis cache. So we are communicating from AKS to OCI cloud. But if we have critical applications that need a proper performance, we maybe don't want to go cross cloud, and we wanted to ensure that a request stays inside a certain zone. And this, we can enable this by enable this locality aware load balancing. So Fabian just did it by reconfiguring our mesh. And if we go back to the Kuma demo app now, we can see a different behavior than before. So we are with our front-end application, we are in this OCI world, and we are just
reaching OCI and the AKS version 2, because the 10% are just deployed. The traffic routes are deployed, and then every 10th call is just reaching the version 2, but we don't see the default AKS zone anymore. If we delete the traffic route, there should be just OCI traffic. I can do that. I'll just remove the split traffic rule. Then we just should get OCI backend. This is just because of the priorities of the traffic routes and the locality awareness.
So this is also something you need to keep into consideration while configuring the policies within the mesh. But from that perspective, so a lot of possibilities that you have with when introducing this mesh or a mesh in this fashion we did for this demo. And it gives you a lot of opportunities. And we just scratched on the very basic stuff here, and we can also extend it to more detailed feature reviews here. So and more advanced use cases also. And it's just a small application here with a small application landscape, just 2 clusters. Imagine you have hundreds of Kubernetes clusters all in one mesh to manage all the services accordingly. So this is the way how it works, and yeah, this is also all we wanted to show, Fabian, right?
Yeah, that's right. I think the observability stuff would be very interesting for many of you as well, but I think 1 hour is just too short to show all the service mesh features in one day or 1 hour. And maybe we'll get back to you and show you the observability features of Kuma as well.
In another session, yeah.
Yeah.
Okay, then just please jump back to the slides for the conclusion.
Of course.
So what we have seen is we showed you the benefits of a service mesh. So obviously increased developers' productivity because your developers can just focus on building application logic and not caring about networking stuff, because the work which a service mesh takes from you is mainly all about network management and control, right? You can call a service mesh like a self-service network management, because before, and what we've seen with the MTLS and the traffic permissions before, if you have classically applications deployed to VMs communicating with each other and you wanted to restrict that, what you would do is configuring firewalls. And now you take this away and give the developers the power to just configure it inside the mesh without reaching out to a separate firewall team. And I think this is also a huge benefit for efficiency. Yeah, and also to ensure reliability with respect to the connectivity, because what we haven't seen and what we haven't shown you, there's also possibilities to configure things like circuit breaker and all those resiliency patterns within the mesh, and not implementing it in your application, just configure it and declare it in the mesh, and also deploy it using a GitOps approach, so that the configuration of your mesh is completely maintained in your Git repository, and all changes are consistently and comprehensible. Also, zero trust security. It's very easy to implement this zero trust security inside the mesh by just enable this MTLS stuff. Doing this by hand manually and implementing it on the service level is a pain in the ass, and you don't want to do that. And it is easy to achieve that with a service mesh implementation like Kuma. Same applies to service discovery and observability, as Fabian was mentioning. We just have to configure this, provide the observability stack, and configure the mesh to provide the respective observability data to the observability stack. And then you have a single pane of glass where all the services inside your mesh and all the health information about your mesh can be seen in a single place. So the key takeaways from our perspective is that the service mesh is essential from our perspective to build and manage multi-cloud applications efficiently. So it is and Kuma as a service mesh implementation, good things is that it's an agnostic approach. So you can also include your VM workloads. You can deploy it basically everywhere. And that's a good thing, because on a modernization journey where most enterprises are currently working on, you cannot big bang replace all your monolithic applications and move them to a microservice world. You need to do this step by step, incrementally, by breaking up your monolithic applications, moving them to microservices, but also need to integrate everything together. And for that, a service mesh in combination with an API gateway is a great fit to support your journey from a monolithic, very static world to a more decentralized and dynamic world with containers, with Kubernetes, with multi-cloud and hybrid scenarios. And yeah, spanning a mesh over multiple clusters is also not that hard with Kuma, so it didn't took us that much effort to set up this demo, basically. So we expect more effort, but at the end, it was quite easy, surprisingly easy, right, Fabian?
That's right. But I think in some more enterprise use cases for some customers with, let's say, OpenShift, it's quite a bit harder, but in the public cloud environment, it is very easy.
Yeah, cool. With that, we are basically done. So here are the materials. The demo source link is still missing, but we will include that once it's published. So let's see what kind of questions we have. So the first question is, can the global control plane be spread across cloud regions? I have to say
I think the question is if there can be more than one instance of global control plane. Is that right? Then I would say it's not possible to have more than one global control plane. So you can't spread it across cloud regions. But you can, of course, use the default region feature to just do a failover to another region.
Now, once your Kubernetes cluster, if you run it on a Kubernetes cluster, once your Kubernetes cluster is multi-region, then you shouldn't have a problem by just increasing the replica count of your control plane, right? Then you are good to go from that perspective. Hope that answers the question. For Canary deploy, can you test the health of the new version and adjust the percentage of traffic dynamically?
So I think the question is especially for the health testing, because we just showed the percentage traffic routing. Yeah, you can also define basic health checks, let's say for an health endpoint, just to ensure that your application is up and running. Yeah, it's possible.
Next question is, I had misconfigured a different mesh and it locked up my entire Kubernetes cluster and everyone else on it. What mechanism is in Kuma are there to prevent something like that?
So I think in Kuma you just give an annotation, or as the default way, you just give an annotation on your namespace. And this annotation is the key for Kuma to inject the data plane proxies next to your applications. And if you don't set this annotation next to your namespace, everything should be untouched by Kuma. And if you don't annotate, let's say the default namespace is like kube system namespace or some other system used namespaces, it should be fine.
I'm not sure if this is if you can completely prevent it, or if Kuma as such had mechanisms to completely prevent a misconfiguration so that everything is messed up. But maybe you can also leverage things like admission controllers or something like that restricts you to change, let's say, the critical namespaces and put some annotations there. So next questions. Is it possible to set up a rotation of MTLS certs?
Yes, it's possible, and it's the default, and you can also configure the rotation interval, let's say for 1 day or 7 days or whatever you want, and Kuma just rotates the certificates and it gets them from its own CA.
And the last, or
let's say in a default way, it's its own CA. You can also use an external CA like HashiCorp Vault, for example, but you need maybe you need a license for that.
So I think the HashiCorp Vault thing is just available in the Kong mesh, not in the Kuma.
It's an enterprise feature, yeah.
Next question. What is the process if you wanted to move a service to a new Kubernetes cluster within the same cloud provider? Would the mesh be available to auto-discover the location? The new Kubernetes cluster needs to be in the mesh as a separate zone. And then you can move around the applications. And as we've seen in our case, when the application is deployed to the other Kubernetes cluster, it's directly auto-discovered as long as the namespace is annotated accordingly, so that Kuma is injecting the data plane proxies. So this is the only thing what you need to do, that you annotate your namespaces accordingly, as Fabian already mentioned, and then auto-discovery shouldn't be a problem. But without annotating, then
yeah,
yes,
I would answer this question with the process could be completely GitOps process. You can just apply all your let's say Kubernetes manifests again, like the Kuma control plane instance and the Kuma ingress and the zone ingress, and then it all should be fine. And you deploy your applications, which has the annotated namespaces within its manifests, and everything should be come up and ready again. Yeah.
Okay. The last question is a follow-up question to the global control plane be spread across cloud regions, and my above question is in regards to high availability. If the global control plane goes down, what is the impact on the mesh? So it's a two-part question. So this is the first part. If the global control plane goes down, your mesh is still working. The only thing is you cannot change the configuration of your mesh, because all the configuration work is done using the global control plane. That's the only impact, but your zones are untouched, so they are still working, right? So this is ensured so by this concept, and then you have the time to bring up the global control plane depending on the frequency, how frequent you change your mesh configuration. But as long as the remote control or zone control planes are available, your service is working, even if the remote control planes in a certain zone is going down, as the data plane proxies are caching the configuration, the service communication is still working. But if the zone control plane goes down, you cannot register new services in your zone. That's the problem there. And the second part,
and also a restart of the existing application would be fading. But so you can say the zone control plane is much more important than the global control plane.
Yeah. What is the best practice for multi-regional redundancy for the global control plane? A single Kubernetes cluster spanning across regions. I would say yes, that's the best practice from our perspective. Having a Kubernetes cluster spanning across regions, and then having more than one replica of your global control plane. Then you are, from a high availability perspective, prepared if one region goes down. So this was the last question, basically. Are there any further questions?
Awesome. Well, I'm going to launch a quick poll here, everyone. Just would love to hear your thoughts on what you thought of today's Tech Talk before you head out. Thank you so much, Sven and Fabian, for this fantastic walkthrough of Kuma, for all your answers to these questions. And thank you to everyone who has joined today's Tech Talk. We also, I'm going to drop a link in the chat. You can join us on the Kong community page. And this is where we have all of our future tech talks. You can get additional communications from us, and there are also links here to join our Slack channel. So if you have additional questions on Kuma, that is a great place to join us and ask them. Our team is there to help out. So with that, I think we can wrap up. No other questions coming through. Let me just make sure. All right. Cool. Sven, Fabian, any final thoughts before I wrap up?
Oh, thank you very much for listening to our talk.
Awesome. Thanks, everyone. And just a reminder, the recording will be sent out later today. So thanks again, and we will see you at a future Tech Talk. Have a great day.
Thank you.
Bye-bye.